Unless you're dealing with them every day, the details of how the option Greeks work can be difficult to remember. In this video, I'm going to give you an explanation of the option Greek theta that should help you better remember what it is and how it behaves. Theta is one of the option Greeks. In simple terms, theta describes how much value an option is expected to lose over the next 24 hours. As it is measuring how an option loses value as time passes, it is also often called time decay. This definition is easy to remember and is fine for a basic understanding. Once you start trading options yourself, though, you may notice that this simple description doesn't always match reality. To explain why, we need to know a tiny bit about differentiation. If you studied mathematics in school, you may remember this already, but if not, there's no need to worry, as this simple definition from a Google search will suffice. As we can see in this definition, differentiation tells us the rate of change of some function with respect to an input of that function. In other words, how much the value of the function will change if we change the input by a small amount. And that's all we really need to know for the purposes of this video. So, how does this relate to theta? Theta, as calculated with Black-Scholes, is the first derivative of the option price with respect to time. As such, it tells us the instantaneous rate of change of the option value with respect to time. In short, the rate the option is currently losing value. In this case then, the function is the function that gives us the option value, and the input of the function that we are changing is time. What this means is if we look at an option's value over time on a chart, the theta value we get from Black-Scholes at any given point in time is telling us the slope of the curve of the option value line. It tells us the angle of the tangent. This is usually quoted as a 24-hour value. In other words, how much this tangent line will decrease on the y-axis over a one-day period. When there is a long time left until expiry, the rate the option loses value is relatively stable. So as you can see, the tangent follows the option value line very closely. Therefore, the Black-Scholes theta is pretty accurate when extrapolated out to the next 24 hours. However, when we get closer to expiry, the rate the option loses value changes rapidly. This means the tangent no longer follows the line closely enough for 24 hours for the Black-Scholes theta to be an accurate estimate for the next 24 hours. The closer we get to expiry, the more likely the Black-Scholes theta figure, which you'll see in option pricing calculators and places like the Deribit UI, is to fail to accurately describe how much value will actually be lost to time decay in the next day. In this example from optionprice.com, which is a useful free option pricing calculator, I've set the parameters to a price of $100, a strike price of $100, and an implied volatility of 50%. With 50 days to expiry, the price of the call option is $7.372, and theta is minus 0.074. If this theta is stable, then 24 hours later, with 49 days to expiry, the call option should be worth 7.372 minus 0.074, which equals $7.298. This does match what we see in the calculator, so the theta proved an accurate measure. However, with 3 days to expiry, the price of the call is $1.808, and theta is minus 0.301. If this theta is stable for 24 hours, then with 2 days to expiry, the call should be worth 1.808 minus 0.301, which equals $1.507. However, we can see that the call is only worth $1.476, so more value has been lost than the instantaneous theta rate suggested. The instantaneous Black-Scholes theta becomes particularly confusing when there is less than 1 day until expiry, potentially showing values that are greater than the total value of the option. With 0.25 days to expiry, or 6 hours, the value of the call is $0.522. The most value the call can possibly lose is this $0.522. But if we only looked at the theta value, as the holder of the call, we might be expecting to be $1.044 worse off by this time tomorrow. Despite this, theta is very useful to track, as it tells you how much it's costing or profiting you to hold your option positions. As we have seen in this video though, it is important to be aware of how the theta you're seeing is being calculated, and when the values are likely to differ from the basic definition of theta that was given at the beginning of the video. It is not always the case that you can look at your theta and come back 24 hours later to find your portfolio has changed in value by your theta, even if everything else like volatility remained constant. You should also make sure you're aware of any differences in how theta is calculated on the platform you are using. For example, on the crypto option exchange Deribit, the theta value shown for options with less than 1 day to expiry is capped at the value of the option. This stops the weird results like we just saw where an option is worth 52 cents but has a theta of more than $1. This adjustment makes sense in terms of what value the option can possibly lose in the next 24 hours, but may cause some confusion if you're comparing it to an option pricing calculator like the one shown. For more information on theta and the other option Greeks, I created the Deribit option course, which can be found here. The entire course is completely free and includes videos, articles, and quizzes. The link can be found in the video description below.